Everyone. Welcome back to my online teaching platform. Still on application of differentiation in relation to normal and tangent to a given curve. All right. Now let's look at our fifth question. The gradient function of the function y is equal to px squared plus qx plus r is 8x plus 4. The function has a minimum value of 1. All right. We have to find the values of p, q, and r. So we have two conditions here. The gradient function of the function is given, and the minimum value of the function is also given. So it means the function has, when it comes to the minimum value, it means the function has a minimum point. All right, the function has a minimum point. So the x value of the minimum point is not given. We have been given only the y value. That is why it is stated as the minimum value. Okay, the y component of the minimum point is called the minimum value. All right. So let us look at how best we can answer this question. So we have to find a solution to this problem. And we have our function to be y is equal to px squared plus qx plus r. And its gradient function is given as 8x plus 4. All right. So this is the gradient function. Now, how do we determine the gradient function? The gradient function is dy dx. You differentiate the function with respect to the independent variable. So given the gradient function to be 8x plus 4, we also need to find the gradient function of the given function on our own and equate it to this since they are the same. All right, so dy dx will give us 2px plus q, and r becomes 0 because r is also a constant. There's no x over there, so you consider it as a constant term. Now, it is given in the statement that the gradient function of the function is 8x plus 4. So this is what we have obtained as our gradient function. And they are saying that it is the same as 8x plus 4. So it means they are equal. So it's going to be 2px plus q is equal to 8x plus 4. All right. So this becomes our new equation. So we need to find the value of p and q using the comparison method. So this is what we are going to compare the coefficient. So the coefficient of x in the left hand side is 2p. The coefficient of xy is 8. All right. So we are going to equate the two coefficient of x. 2p must be equal to 8. So this will give us, we now get 2p equal to 8. Then we divide through by 2 because we are looking for the value of p. So we divide through by the coefficient of p. This implies that our p is equal to 4. All right. Then we take the other one too, the coefficient, and see what we get to. So the coefficient, okay, this is a constant term, which is q. And here too, we have a constant, which is 4. So we conclude that our q is also equal to, the q is equal to 4. All right. So we have p to be equal to 4 and q also to be equal to 4. All right. Let us continue. So we now substitute the values of p and q into the given function. So we have y equal to px squared plus qx plus r. So we are going to replace p and q with their values. So y will be equal to 4px squared plus 4x plus r. Okay. Now let us look at the second condition. You have given another condition which says that the minimum value of the function is 1, right? So let us illustrate that one. Let us look at it. So let me use my straight edge. I'll get a straight line. Okay. So this is my x and this is my y. Minimum means your curve. This is how the parabola will look like. So minimum. This is where the minimum point will be. So these are minimum point. All right. And they are saying that the minimum value is 1. So it means at the minimum point, yeah, y is equal to what? 1. Okay, so I obtain it by tracing it to the y-axis. So it means y is equal to 1, and that is the value given as the minimum point. Right. Let us get a tangent at this minimum point. Okay. I wanted to get a tangent at this particular point. Okay. 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 So now we have our tangent here. This becomes our tangent. So the line that touches the curve at the turning point is known as a tangent. All right. Now you can see that the line is parallel to the x-axis. Okay. So let us find the gradient of that line or of the tangent and see what will happen. So you can pick any 2 points on the line. So I'll pick one here. I'll pick maybe here to be A and here to be B. Right. So I'll name the x component of the point A to be x1 and the x component of point B to be x2. All right. Now, the y component is y1, and that is the same as the y2 because you only have, you cannot get any other y value on the line which is parallel to the x-axis. You only get you only get one y value because when you trace the line to the y-axis from A, you still get the same y value. When you trace from the B to, you get the same y value. So the y1 is equal to the y2. So when you find the gradient, you see that when you subtract the y1 from the y2, you get a result of 0 because they are the same. Divide by x2 minus x1. And anytime you divide 0 by any number, you are going to get a result of 0. So anytime you have a tangent, and that is the gradient of the tangent because that is the line touching the curve at the turning point. So anytime you have a curve and you have a tangent to the curve at the turning point, the gradient of the tangent is equal to 0. And since the gradient of a tangent is the same as the gradient of the curve at where it touches the curve, at that particular point, the gradient of the curve is also equal to 0, right? So you continue by saying that at TP, which is turning point, at TP, our gradient must be equal to 0. All right. The y ds is equal to 0. So we know our gradient function to be 8x. So this is our gradient function, which is 8x plus 4. So this must be equal to what? 0. So we are now going to find the value of x for which the gradient is equal to 0 at that particular point. All right. So we have 8x to be equal to negative 4. Then what we do? Divide through by the coefficient of x. So 8x we divide by 8, then equal to negative 4 also divided by 8. All right. So we are going to get a result to be x is equal to negative half. All right. So this is the value of x at the turning point, and we have to write it as a point. So we are going to get it as negative half, and the value of y over there is 1. So negative half against positive 1. Let us now look at the value. Let us look at the value of r. That's the only thing left for us to look at. Now, let's go back to our graph. Right, so it means at this point, at this particular point, here will be negative half, then 1. So that's the turning point. Yes, that is the coordinate of the point where the curve turns. All right. Now you could say the coordinate or the point is on the curve and at the same time on the tangent. So anytime you have a point on the line or on the curve, that point satisfies the given curve or the given line. So let us bring back our curve. Y is equal to our curve. Y is equal to px squared plus qx plus r. Know the value of p to be 4. So 4x squared plus 4. Q is also 4. 4x plus r. Now, since the turning point is on the curve, it must satisfy the curve. Okay. So we know our y component to be 1. Our x component is negative half. So you plug in negative half for x. Then it's having a square plus 4 multiplying negative half plus r. Okay. So this will give us 1 is equal to 4 multiplying negative half squared will give us 1 out of 4 plus, okay, 4 times negative half will give us negative 2. Right, we are going to get negative 2 here, then plus r. Then we continue to, we are going to get 1 is equal to 4 times 1 out of 4 will give us 1. Right, we are going to get 1 over there. 1 minus 2 plus r. Now need to work on it. So we're getting 1. 1 is equal to negative 1 plus r. And we want to make r. So we have negative 1. Sorry, we have positive 1 plus 1. We have transposed the negative 1 to the left hand side equal to r. So this will give us a result of 2 is equal to r. Okay. So we have our p to be equal to 4, our q to be equal to 4, and our r to be equal to 2. All right. Thank you for watching. We'll be answering more questions on this particular concept. Please do not forget to subscribe to my YouTube channel and also share with others to comment and also like my videos. So, bye bye for now.